Hey, what is going on, everyone? Welcome back to another video. Today I'm going to be covering points and slopes. It's one of your assignments and kind of just the way that we're thinking about a problem like this. So let's think of a problem. Actually, what I'm going to do is let's just go back here, steal this one from the last video, and also let's go ahead and let's steal from ourselves. Really, I keep saying the word steal. Is it stealing if you've already solved the problem to take the solution and use it somewhere else? Hopefully, you're like, no, that is not stealing. That is being wise. That is working smarter, not harder. And I want you to think about that. If you remember the answer to a problem and you've used it before, that gives you a huge advantage that you don't need to spend a lot of brain power thinking about it. You might have to quickly redo the work, but you know the answer already. Most of the thought is gone. And really, that's kind of the hope with doing these problems, doing so many of them, is that you see so many of them that you just are like, oh yeah, it's this. And you just know it instantly. So when we do this process and we solve it down, we want to remember, okay, what we're doing here is we have y equals mx plus b, our slope-intercept form, which is the best form for graphing a line because it gives us so much just instantly that if we come in here and we make ourselves a little sketch graph, which keep in mind when we're talking about our graphing, this is kind of my expectation. You showed me before, we've tested over, can you, given a nice graph, can you make a perfect graph? Great. You've shown me that you can do it right. You don't need to do it perfect every time because you're communicating to me in a way that I don't want you to spend a lot of time communicating this part. I want you to show me that you know the other stuff. I want to move past can you graph. So this is kind of my expectation of what a graph for something like this should look like. So when we're looking at this, we should have here our y-intercept. This is our start value. So like we said on the last video, this is 2.25, which means we come in here and we can plot our first point as being right about there. Now, it's a sketch. I don't care if it's perfect. I care that it communicates what I want. So this is kind of like this bullet point list. It doesn't have to be a perfect 5-page paper telling me something. This is bullet points. Get the message across. So we have our y-intercept here. Looks perfect. And then we want to go to our slope, which we always want the slope as a fraction. Because when we're looking at this, we're going, okay, we're going to go down 1, we're going to go down 2, and we're going to go down 3. So kind of just think this through. Since we're on quarters, that this 2.25, then we're going to go down to 1.25. Then when we're coming down off that to get down one more, think about it, 1.25, we're going to go down to 0.25. And then when we subtract off that last one, we're going down to negative 0.75. Now this point's not going to stay, but this is just kind of to give you the visualization that that's our change of 3 that we're going down. So then we're going to go over 4. 1, 2, 3, 4. So our second point here is going to look something like this. And when you're making your graph, then we care, wow. Try to make it as good as you can. Try to get as straight of a line. If you have technology like me that lets you cheat and just make a straight line, great. If you have just a piece of paper next to you, it's a piece of technology that lets you make a straight line. Use it. We want to make these look as good as we can. I always want to see you connect your dots. I always want to see arrows at the end because it's a line. All of these are lines. They go on forever. I also care that your arrows get off of kind of this little graph area that we have. Because a lot of times what I'm judging is I'm judging where do you exit your quadrant. I'm judging solely based on those outside parts, and then I work my way in. So if you go all the way out, it communicates to me instantly that you know what you're doing. So just some advice. If you want to make sure that your grade is good, make it easy for me to see exactly what you're doing. So this is kind of just our general, how do we graph from y equals mx plus b. And this shows why it's so nice when we get a y equals mx plus b equation. So this tells us we always want to work from y equals mx plus b. So what happens if we're given, say, negative 13.5, and let's go easy. Let's say they give us the slope, and they say that our slope is 7 divided by 5. So when we're talking about an equation like this, we want a y value, we want an x value, we want an m value, and we want a b value. Let's fill in what we know. Okay, we have a 5, negative 13, and 7/5, and we don't know this one. So when we fill in our equation over here, and we get 5 equals 7/5 times negative 13 plus b. We have one statement and we have one unknown. So we can solve for that b value. Now, take a moment, pause the video, spend 20 seconds and see, can you get the b value on your own? If you can't, no problem. Come back to the video and we're going to walk through it. So, when we're looking at this, we're going to get 5 equals that negative 13 times 7. And if you're like, I can't do that in my head, guess what? We have these really cool things, calculators. If you don't have a calculator, like I have my TI-84 here in front of me, grab your phone. If you have an iPhone, maybe play the fun game of, Hey Siri, what is 7 times negative 13?
It's negative 91.
Good, thank you, Siri. Negative 91/5 plus b. So now we've combined our like terms, we've multiplied. Going back to our PEMDAS over here, we didn't have, well, we had parentheses, but those parentheses really weren't parentheses. Those are really just a way of saying you're multiplying. So we multiplied. We don't have division that we can really do. If you want, you can make this a decimal if you want. Great. Otherwise, you don't have to. But now we're to the addition, subtraction. So we have subtraction, so we're going to take here and we're going to add 91/5 to both sides. And we're going to get 5 plus 91 divided by 5, which gives us, I'm going to go decimal, 23.2 equals our b value. So now we have a b value, which means we can say that our equations now go back to y equals that 7/5 x plus our b value of 23.2. And from here, we can graph this. And in fact, I want to graph it because this one shows something really important. And I'm going to tell you right now, you're going to see problems like this. And in fact, on the homework assignment, you've seen or you're going to see problems where your y-intercept's kind of useless. This plus 23, that on the scale we have, if we keep going like that, that's going to put the y-intercept way up here on our new equation. Let's get rid of those. So our y-intercept being way up here isn't very helpful to us. So let's think, is there a way we can graph this without having to resort to making this huge y-axis? Take a moment, think about it. And while you do, I'm going to kind of set this graph up a little bit more. All right, so hopefully you've kind of thought it through a bit. I'm going to try to square up these things. This is the one problem with when you're trying to make a sketch of a graph, is that it's really hard to get it exactly symmetrical and where you like the way it looks. But it's part of it, and you get better at it the more you do it. So hopefully you have a thought. If you don't, no worry. You're going to get better at this. Algebra 2 is hard. It's supposed to be hard. I think a lot of the math classes that you've taken don't show that. Like, math is really difficult. And if you have friends who are like, oh yeah, I love math, it's easy, I'm going to tell you, just watch them. Because eventually they're going to hit a math class where it's hard. And they're going to understand a lot more how you feel. For me, that class was Calculus 2. Because that class, still to this day, I have a whole degree in math. I still don't like that class because it's still the hardest class I've taken because it just doesn't make sense in my brain. But I've worked very hard and I understand it better than most people. But it's a tough course, and that's something to keep in mind. This should be tough. If it's not, great. Keep pushing. You're eventually going to find that thing that's hard. And that's the thing worth pursuing. So, when we're looking at this, we don't have to plot a point way up here to get a nice graph. When we're looking at this problem here, we can say, okay, they gave us a point. And what do we need to graph a nice line? Well, a line passes through any 2 points on that line. Really, it passes through infinitely many points, but we really only need 2 points to make a nice graph. And, well, we have a point that's kind of nicely located. It's a lot better than 23. So let's think about, okay, we're going to go with our wrong pen size and a different color. This is our change in y over our change in x, or how much we need to go up divided by how much we're going to go over. So let's think about this. We're going to go up 7. So from our 5, I'm going to do it in blue on this axis. 1, 2, 3, 4, 5, 6, 7. And we're going to go over. I'm going to highlight it on this axis in pink. 1, 2, 3, 4, 5. So this gives us a slightly nicer point to graph that we're going to go right here. And now we have 2 points that are on this graph that we've made. We didn't have to graph this point way up here. And now we just come in and we can go, okay, maybe grab your straight edge here. And come on. Get your line. And you see, with that, we didn't have to make this huge graph. We could just make it work from finding with this point and the slope. We could just make the graph instantly from knowing those 2 bits of information. We didn't need B to graph it. we needed b to state the equation. So that's something to keep in mind when you're dealing with a problem like this, where you're given a point in the slope. You can graph it, but you can't state the equation instantly. So, kind of the next evolution, the next problem from this is, okay, what if you're given 2 points? Well, if you're given 2 points, essentially you're just starting from one step further, and then you're going to get to the exact same point. So we want y equals, x equals, m equals, and b equals. Okay, well, we can pick either x or y. I'm not going to do that yet, though, because we don't know m and we don't know b. So that means we can't use this equation yet. We need a different equation. Hopefully, think about, do you know what equation we need? Take a second, think about it. Try to bring it up. But hopefully you remember that we have this other equation. We have the slope formula. M equals y2 minus y1 over x2 minus x1. So, plug in your values. Make sure you got to be consistent. You have your y's. You have your x's. They have to line up. You should have 1 point listed out and the other point listed out. So, when we plug in our values here, I'm going to go ahead and do 6 minus 2 divided by -7 minus 5. So we get 4 divided by -12. And we can simplify that. We get -1 over 3. Now, just to kind of prove a point here, and to review something that is a mistake that just happens over and over again. What happens if I went 2 minus 6 divided by 5 minus -7? Okay. Well, let's work through it. 2 minus 6 is -4 divided by 5 minus -7 is really adding 7. So I get 12, -1/3. Hey, it works either way, whether you choose this to be 0.1 and this to be 0.2, or this to be 0.1 and this to be 0.2. Doesn't matter either way. But now we have a slope. So now we can come in and say, okay, we have -1/3, and now's the time to choose a point. So it's up to you which point you want to choose. Is there one that's going to be nicer? Personally, when I'm looking at this, I'm probably going to go with, let's pick -7, 6. Because these negatives are going to cancel here in just a moment. So plug it in, y equals mx plus b. So we get 6 equals -1/3 times -7 plus b. Cancels out the negatives. 6 equals 7/3 plus b. 6 minus 7/3 equals our b value. And we should get a b value of 6 minus 7 divided by 3. We get 3.666666. Goes on forever. That's what this little bar tells us, that we're going to just keep having 6s until, well, forever. There's never going to be a last 6. Now, this is where the b value for graphing, great, the decimal works. But the problem is that we don't usually write this little bar over our answer. A lot of times we round things to say, in my class, 2 decimal places. We always round to 2 decimal places. Well, this is not actually, given these points, this isn't true if we get rid of that bar. We have lost accuracy. This is not the correct answer anymore. It's acceptable in this class, but it's not precise. So that's where the fractions become really important. But for the sake of what we're doing, it works. So we can say that our equation is y equals negative 1/3 x plus 3.666 repeating. And that is good enough for our green highlight of correctness. So, these are just some examples walking through, hopefully giving you the steps that we're going to go through and how we're going to do these problems. But please, once again, as with everything, if you have questions, please comment. Please come into the classroom and talk about these things. Ask questions, because this is the foundation of what we're going to be doing throughout the rest of the year. I hope this makes sense. I hope this helps you, or maybe just is a nice refresher on the steps. So please come in, have a great day. I will talk to you all next time.